Okay, this is 3A notes. So simplifying radical expressions is the first part, containing negative rational numbers. And then we're doing higher powers of I also. So there's two different parts to this. So the first thing is just keep these, this is previous material that you've learned in the past, probably Algebra 1. And just keep this in mind, we're doing the same type of stuff. So square root of 16. You might know that as 4, but you don't really, there's a way to break it down, I should say. You can do what time two numbers multiply to 16. Some of you have seen this tree before, so 4 times 4. You could think of it as a square root, so you need pairs. So you could even break this down further. 4 and 4 is 2 and 2. 4 and 4 is 2 and 2. And those are prime numbers. 2 is a prime number. What I do is I tend to circle those 2's. And then I look at, since it's a square root, I need pairs. So a pair of 2's is 2. And another pair of 2 is another 2. And you multiply them together, which gives you the 4. So you could just know off the top of your head, square root of 16 is 4. Otherwise, you could break it down into prime numbers. So like looking at the second one here, we have x squared. Well, how does that break down? That's x times x. That's what these factors just mean multiply. There's multiplying in between each one. So we have it broke down. X can't get broke down any further. It's a square root, so you're looking at pairs. Well, there's a pair of x's. So square root of x squared is just x. Looking at the next one, we have square root of 98. Well, that's not a perfect square like the first two are. They simplify down to a perfect whole number or variable with nothing left over in the radical. So a 98, we can't really break that down. So what we do, or we can't break it down to a whole number. So we're going to keep working, and we're going to do the factor trees. What two numbers multiply to 98? 49 and 2. 2 is a prime number. I circle it because then I know the end of that prime, that factor tree is done, that branch. And 49 is 7 times 7. And 7 is a prime number. Prime number means it's only multiplied by 1. It's the only way to get that number. It's a square root, so we're looking for pairs. There's only a pair of 7's here. So that comes out as a 7 on the outside. And then on the inside, there's still a 2 left over, so it's 7 square root of 2. Some of you might also look at this as, you break it down into square root of 49 and 2. And the square root of 49 is 7. And then there's a square root of 2 left over. So that's another way to do it. Last one is x to the 5th. Well, that one breaks down. With x's, I just think of it like I just break it down to x times x times x times x times x. There's 5 x's multiplied together. It's a square root, so how many pairs? 1 pair, 2 pairs, and 1 left over. So each pair comes out as just an x, and times another x, and then there's a x left over, so that stays underneath the square root. Now if we simplify this a little bit more, x times x on the outside, that's x squared, and the square root of x is on the inside. All right, so one of the key concepts for this, so that's previous material. There's one thing I'm really going to add to this, and that's the square root of -1. And if you do that in your calculator, the square root of -1 is going to give you, it's going to give you a non-real answer. Well, there's things called imaginaries. So anytime you get the square root of -1, that's the same thing. We're just going to represent it as I. So it's going to be an I. So anytime you see a square root of -1, you can just rewrite that as I. Like pi is a number, 3.141592, but we just write pi. So square root of -1, that's I. So looking at example 1, we have the square root of -64. Well, we know what square root of positive 64 is, but the -64, we need to break that down. So what I do, -64 or can be multiplied -1 times positive 64. That gives you -64. So these two, -64 and -1 times 64, are equivalent. So they're the same. The reason why I write it like that way is now if I break it out in the square root of -1 times the square root of 64, we know what the square root of -1 is. We just did that up here. So that is I. And the square root of 64, you can know that as a perfect square, or you can break it down into 16, 4, get your perfect squares. get down to your prime factors. Pair of 2s, another pair of 2s, and another pair of 2s. So we have 2 times 2 times 2, that's 2 times 2 is 4, times 2 is 8, and I. We tend to write, just like our variables, we write the I after the coefficient. So 8i that would represent. So if you see it at the very beginning, you just know the square root of 64 is 8, and then you have the negative is I, that's fine. You don't have to actually multiply it out. I'd like you to know that the factor tree, though, that way of doing it for tests, and if you ever get to a problem where you don't understand. So, all right, example 2. So we got to break it down again. We have the square root of -1 times 54. The goal is to get the number to be positive, so then we can actually take the square root of it. So we have square root of -1 is I, and then 54 get broke down into, I know it's an even number, so it's got to be divided by 2. 27 can be divided by 3. 3 is a prime number, and 9, 3 and 3. All right, it's a square root, so we're looking for pairs, square root pairs. So we have 3. Now 3 and 2 are not pairs. So we need those stay underneath the square root. The I can come out of the square root. And then underneath the square root, we're going to keep 2 times 3. Now we look at this, can we simplify it? We have to simplify that a little bit. And we can, to 3i square root of 6. 2 times 3 is 6. That's your final answer. Or final simplification, I should say. All right, example 3. Now we have an integer, so -32, and a variable x squared inside the square root. So we're going to do the exact same thing. Square root of the negative, we can bring that out as -1. So -1 times a positive 32, and you could even do it times x squared. If you really want, you can break this out into square root of -1 times the square root of 32 times the square root of x squared. Square root of -1 is I. 32 square root of 32, I don't know. Break that down. So 8 and 2, 4 and 2, 2 and 2. And it's a square root, so pairs 1, there's 2 pairs. So I should probably move this. So this equals, that was I, 1 pair of 2s, there's 2 pair of 2s, and there's a 2 left over. That's underneath. The x squared is x times x, there's 2 x's, so that comes out, there's 1 pair. And let's simplify this down here. We have 2 times 2, so the coefficient, the number goes first. Then it doesn't really matter if you put the variable or the imaginary. Typically it's the variable, then the imaginary, and then the square root. And that's your final answer there. All right. Last example is we have a number on the outside, an integer, and we have a number on the inside and variables. So we got a lot of stuff going on, but we can just take this slowly, one at a time, and we'll figure this out. So let's divide up that. They get that -4 out of there, so -1 to make it positive. And then let's split it up. And some of these steps you can absolutely cut out if you want. If you feel comfortable, or once you get comfortable with these, you can split some of these steps. You can take some of these steps out. All right, so we have -5. Square root of -1 is I. Square root of 4 is 2. There's all multiplications in between. X to the 4th, there's 4 x's. Square root of that is x squared, so x times x. Or you could write x squared. Y to the 7th, let me write that over here so you can see it a little bit better. that would break down into 1, 2, 3, 4, 5, 6, 7 y's. 7 y's multiplied together is the same thing as y to the 7th. And when you take the square root of that, you're looking for pairs, so you get 1, 2, 3 pairs. So we're gonna have 3 y's on the outside and a y left over on the inside. Now let's simplify this. -5, oh, not -5, because we have that 2. -5 times 2 is -10. And then x, we have x times x is x squared. Y times y times y is y to the 3rd. And then there's an I left on the outside and square root of y. Looks pretty ugly, but that is the simplified answer there. All right, cool. That's notes on simplifying the square root of -5.